Okay, simplifying complex fractions. Complex fractions are just fractions that have fractions within them. Okay, now they can look overwhelming, but we actually have two methods for dealing with this. The first is a way of reducing the problem to something that's a little simpler to look at. When you look at it initially, it looks like a big mess. Basically, what we're going to do is just work with the numerator, which I'm going to do in green, and simplify that as much as we can, and then work with the denominator, which I'll do in blue, and simplify that as much as we can. Once we do that, we will just view this as a division problem. Okay, this big line here that separates the top and the bottom of the complex fraction is just a division sign. So really it's kind of you look at it as if it has three different problems within it. Okay, but to compartmentalize those will make it a little easier for you. Alright, so I'm just going to work with the top initially here and not even mess with the bottom. Okay, so here's the black line that separates the top and the bottom. And I look at the top and I say, okay, I need to add those together. Alright, I need to get a least common denominator. Okay, and in order to do that, if I look at my least common denominator for the top, it's pretty simple. It's just going to be x plus 2 and x minus 1. Okay, so I'm going to use that to help me out on the top. So if I look, my first fraction needs an x minus 1, so I'm going to put an x minus 1 over x minus 1, and I'm going to multiply that to the top here, which was 1 over x plus 2. Okay, and that's going to be added to 3 times x minus 1. Now my x minus 1 needs an x plus 2 with it, so I need to multiply that by x plus 2 over x plus 2. For now, I'm going to completely ignore the bottom of the complex fraction. I don't need to worry about it right now. Once I do that, I have a common denominator up top there, so I can distribute these. Okay, I'm going to have my x plus 2. Here's my common denominator, x minus 1. And I'm going to have my x minus 1 plus 3 times x plus 2 here, so I'm going to have to distribute this 3. So I get 3x plus 6. Okay, next, I just need to simplify that top a little bit more, and so I end up with 4x plus 5 all over what I determined to be the least common denominator for the top of this complex fraction. Okay, so if you look at it there, I just completely ignored the bottom, simplified the top. Now on the bottom, if I factor x squared minus 1, that actually factors to x plus 1, x minus 1, right? If I do that and I see that is what it factors to, you'll notice that that becomes our least common denominator. And that the first fraction in the denominator, 2 over x squared minus 1, really doesn't need anything for its common denominator. So we can just put this as x plus 1, x minus 1. Okay? Plus my 1 over x plus 1. The x plus 1's a little lonely there. It needs an x minus 1 with it. So we got to multiply by x minus 1 over x minus 1. Now we have our common denominator in the bottom of this complex fraction. And I end up with 2 plus the quantity x minus 1 all over x plus 1, x minus 1. So I'm just working with the bottom there. And if I simplify that, I end up with x plus 1 over x plus 1, x minus 1. Now, is the bottom as simple as it can get? No. We can actually cancel out that factor of x plus 1. So I go to rewrite this again, and again I have 4x plus 5 over x plus 2 times x minus 1. That's my top. and my bottom is now reduced to just 1 over x minus 1. Now, once you get these to the simplest form that you can, you need to understand that this black line here just means division. That's all it means. So, I have my 4x plus 5 all over x plus 2, x minus 1. And that's really being said, this complex fraction is just really saying that you're dividing that by 1 over x minus 1. Which division problems can be rewritten as multiplication problems. So we could rewrite this as, again, 4x plus 5 over x plus 2 times x minus 1 times the reciprocal of our divisor, x minus 1 over 1. And then you'll see, because it's multiplication here, we can cross cancel, leaving me with just 4x plus 5 all over x plus 2. And that's your final answer. In this problem, it's a little tricky, but you go up to the original problem and you'll realize that x could not equal -2 or plus or minus 1. Okay?